G'day good people, Rob here, Tasman Energy, Down Under in Tasmania, Australia. Welcome to part 3 of the solar system installation series on putting in a small standalone solar power system. In part 1 we put in the battery bank here. In part 2 we got up on the roof and we put up 6 solar panels. They're 275 watts each and they're connected in 3 series pairs. Today I'm going to start connecting this system up and hopefully get it commissioned so I can enjoy the power and stop using a generator to run this shed. To commence the installation I need a thing called a solar array disconnect, and for that I'm going to take up an outdoor enclosure. It's an electrical enclosure and that's going to house a triple module solar circuit breaker which will provide a means of disconnecting the solar array while I'm working on the system and if there's ever any fault in it. I'm going to put this disconnect on the roof. It's actually a requirement to be able to disconnect your solar array up at the solar array. Once I get the solar panels connected into this circuit breaker, I'm going to come out the bottom of the module box holding it. I'm going to come out the bottom of that in 25mm conduit. And I'm going to take that 25mm conduit down through the roof through a thing called a Dectite, which will seal the roof penetration and stop it leaking water. Then I'm going to come back down and I'm going to run 16mm builder's wire. It's a double insulated wire, very good for solar arrays. In this case it's big enough to handle the current, but you can use a voltage drop calculator to determine the correct cable size for your array if you're using a bigger solar array or a longer run than I'm using. And this is going to go up through the 25mm conduit and into the bottom of this circuit breaker. At least the positive is going to go into the bottom of the circuit breaker. The negative is going to come up into the circuit breaker box and it's going to connect to the solar panel negatives. The solar panel positives will each go into the top of the circuit breaker. So we're pretty much ready to go up on the roof, drill the roof penetration, mount the outdoor enclosure for the circuit breaker, put the conduit in, then come back down and run out the wire that's going to carry the current from the solar array through to my solar regulator. So let's get up on the roof and get started. Right, what I've done here is I've connected my outdoor enclosure for the solar array circuit breakers to a support leg. I've firmly riveted that on with aluminium pop rivet so there's no dissimilar metal corrosion, and that will take the circuit breakers for the solar, or the disconnect switch for the solar array. I've bought my 25mm conduit up through the roof using a device called a Dectite, which I've sealed to the roof using roof and gutter silicone. The conduit comes up. I'm not connecting it to the bottom of the outdoor enclosure yet, because before I do that it's easier to get the wires through when it's just hanging loose. I'm going to go down the bottom and I'm going to push the solar feed wires up through this, and I'm going to run them through to the circuit board next to the battery bank. Right, I'm back down off the roof. Here on the floor I've got 2 rolls of 16mm builder's wire. It's double insulated. If I peel off the outside insulation layer, which is white, one's coloured red and the other's coloured black. I'm going to roll them out on the floor to the base of the power board, tape them all together and get a nice straight line of wire, and then I'm going to thread it up along the roof battens and up through the roof penetration, which is here, and that'll put the wires up to the solar array. So I'll go ahead and do that now. Here's my solar feed wire. It's neatly taped together at about 1 metre intervals. So I'm going to take this piece of wire now and I'm going to feed it up over this rafter that's here and along this roof batten, and then up through the hole in the roof and out to the solar array disconnect. Right, here I am back up on the roof. The beautiful sunny day we had yesterday's gone. I didn't get it completed yesterday. Today it's threatening with rain. It's dull and overcast, but I'm going to try and get these panels hooked up so I've got some power flowing to my batteries. First thing we're going to do is make a series pair out of the first 2 panels. And to do that, I'm going to unclip the leads. They were just tied off there in the factory. And the series pair connection is super easy. These panels come with flying leads with plugs on them. I'm going to simply plug one panel into the other, like so. And I've made a series pair. Probably best to leave that till after you've wired it up, but because it's threatening with rain I'm in a bit of a hurry. I'm going to connect this series pair through to the box we put on yesterday. And to do that, look, if this was a job that you were paying me to do, I would have gone to an electrical shop and I would have bought the correct leads that would simply plug into here and end up down at that junction box. In the interest of doing it super cheap with what I've already got, I'm not going to do that. I'm going to use twin core 4mm electrical flex, and I'm going to snip these two plugs off, bare back the wires, connect them into this electrical flex. The electrical flex will run neatly up inside this channel, no one will ever know. It'll do just as good a job as a bought wire, and it'll be clipped on here. I'll bare back these wires, I'll join them together with a crimp connector, just using a simple little crimping tool, and go ahead and get the connections all the way through. Hopefully I'll get it done before it rains, and I'll come back and give you a tour as after I've wired the 3 series pairs in and it's done. I've got 3 pairs of solar panels wired together in series. I've got the positive and negative leads coming out of those, crimped to wire and heat shrunk on and following the channel down that supports the array underneath it out of the weather. It's held in position with the cable ties, you can see. It comes down to the solar array disconnect, which I've got mounted on a strut out of the weather. The solar array disconnect simply allows me to turn the solar array off and on the roof. And you should note, years gone by, 20-30 years ago, when we used to put these arrays in, there was no such thing as a solar array disconnect. We used to just put a junction box here and hardwire everything all the way through to the power board. Better to have a disconnect on the roof, and rather than using circuit breakers, which I've done, you would be better off buying a dedicated solar array disconnect switch. From the bottom of my disconnect switch, I'm coming down through 25mm corrugated conduit, through a deck tight, through the roof, and the wires then run on down a roof batten and end up at the power board ready to connect into the regulator. Here I am down at the power board. The solar array is completed up on the roof. I've left it turned on so I can demonstrate and also test my leads coming down. I have got my voltmeter set to volts DC. We've looked at the placard on the solar module, and the placard says we should get around 80 volts as an open circuit voltage. So the first thing I'm going to check is the open circuit voltage of my solar array. Now bear in mind, 80 volts is enough to give you a bit of a belt. I don't want to touch the positive and the negative. It gives you quite a good tingle. But I can put the multimeter leads on them. And I can look at my voltmeter there, and it says 71.4 volts. 71.4 volts is about what I'd expect. There's late afternoon sun at an oblique angle on the panels. The midday sun should give slightly higher voltage. Now a solar panel, you can actually short circuit it together, and this is why just a switch on the roof is required, not a circuit breaker, because a fault in the array will not trip that circuit breaker. If the fault in the array tripped that circuit breaker, the circuit breaker would also trip as it provided the current to the regulator. If I touch these together, I'll get a welding type current, and doesn't hurt the solar panels. Short circuiting solar panels doesn't hurt them. I'll go back up on the roof now and I'll turn this off so there's a dead, and there's no voltage present, and I'll go ahead and I'll mount some components on this board, and we'll do the fun part, which is putting all the components on, hooking them up and actually getting some power. What I'm putting up is a solar controller. This is a Plasmatronics solar controller made in Melbourne, Australia. Great quality bit of kit. Don't let the small size fool you. It's got a full-on microprocessor in it, and it with a device called a PLS shunt adapter. And a shunt will not only control the solar, it will measure what goes in and what goes out of the batteries, and it'll give me a percentage battery capacity, so I always know what the state of charge is in the batteries. The inverter, I traded this inverter in years ago. Hope it works, I'm sure it does. Did when I took it out. It's a Electronic 7,000 watt inverter. It's got a 15,000 watt surge. It'll run all the really big power tools in this shed. Maybe a little bit big for this battery bank. I don't care, this is what I've got, this is what I'm using. Great inverter. couple of circuit breakers. They're going to protect the solar feed up to the solar array. Battery fuses, of course, circuit breaker holder, a few miscellaneous bits of wire, little tiny fuse for the sense wire on the solar controller, which goes directly to the battery terminals. And that's the basis of my solar system. I've also got a thing called an auto transfer relay. This will interface, also made by electronics by the way, great thing. This will interface between the inverter and the generator. As you can see, I've got all the components now attached to the power board. My inverter here, my solar regulator here, the battery fuse we put in with the batteries. I've got a couple of circuit breakers here for the solar system and the solar regulator, and I've got an auto transfer relay up here to distinguish between generator power and inverter power. I've hooked most of it up. This is actually simplicity in itself. The two solar feed wires we put in earlier, the positive and the negative from the solar array, come down. The positive goes through a circuit breaker here and onto the battery. The negative comes down to the Plasmatronics solar regulator, which regulates the negative side of the solar array, and then onto the negative connection of the battery at the top of the battery fuse. The inverter wires come down here through the board and into the top of the battery fuse. And it's a very, very simple process of putting red on red, black on black, and just following the instructions of the equipment manufacturers. So it's all connected up, pretty well ready to go. We're going to have a quick tour of what's here and then go and fire it up into life. Well, you can divide a solar system up into 4 basic components. Here's the first component. This is our 6 275 watt solar panels we put on the roof earlier on in the installation. They're arranged in 3 series pairs and they form a 1.6 odd kilowatt array. This is the next component of the solar system. It's a 15 kVA single phase generator, an X-Coat's highest service unit I got from a machinery auction in Melbourne. 30,000 odd hours on the clock, but it runs very, very well indeed. This component here ran the workshop for nearly a year prior to putting the solar system in. It's not redundant. I'll still use it occasionally if I've got really, really big wood machining jobs to do. But I'm quite happy with the solar array and the inverter and the batteries for 99% of my power needs. The requirements are met just by that. The last major components of the solar installation, of course, is the battery bank and the power board. Battery bank on the left we put in earlier, 220 amp hour golf cart batteries. On the left-hand side is the power board, 7 kVA inverter, battery fuse, Plasmatronics solar regulator, and an auto transfer relay. And here it is, the moment of truth's arrived. Will it work or won't it? Well, of course it works. I'd be bullshitting you to say I haven't tested this system. It works absolutely fine. I tested it because nobody wants to put a smoking failure of a solar system on the internet. It's a goer. To get it going, all we've got to do is put in the battery fuse. Here it is hanging here. Shut the battery fuse home. Nothing very dynamic happens because electricity can't be seen. But I can go up here, turn the inverter on. A few seconds later, I've got the green power light. I've got 240 volts flowing through the workshop. I can turn the solar regulator on and it tells me the batteries have got 54.6 volts in them, which is pretty well fully charged. And then I can turn the solar array on and I have amps flowing into the battery bank from the solar array. So the system's finished, runs all my power tools, runs the lights, quite a reasonably priced power system, a great system, one that you can easily source the components for yourself and put in yourself. Before I go, there's another couple of things just to quickly show you. Up above the battery bank here, I've got some pure water, distilled water if you like. I just bought pure water from the supermarket, and I've got a garden spray bottle from the local hardware store. Very cheap spray bottle, a bit of distilled water. I use the spray bottle dedicated to the solar system. It won't be used for anything else. I won't put any chemicals in it or anything like that. It makes filling up these batteries a breeze. People complain to me about flooded lead acid batteries, saying, oh, you've got to maintain them, you've got to put water in them. Look, once every 6 months, I'll take the caps off. I fill up my spray bottle with a bit of water. It takes about 5 minutes to top them off. I'm going to go ahead and do that now. The batteries are being commissioned for the first time. I'll check the level and unwrap my spray bottle, Fill them up and the system will be good to go. Thanks for watching. Rob from Tasman Energy, Down Under in Tasmania, Australia.